Hello all, welcome back. So in this module, we'll be discussing about total metal concentration in sediments and how to use this total metal concentration in sediments to assess the marine environment or the sediment quality. So, I'll just go very briefly how we collect the sediments and how we process the sediments and how we determine total metal concentration in sediments. I have shown some of the sampling procedure, like spade core, Van Grab, gravity core, and even the pipe that we use it to collect sediment core. So here, spade core and gravity core, usually we use it in open ocean where the depth is more, and these two core can give you proper sediment, surface sediments, and the down core profile of the metals. But Win Van Grab, these things this grab we use it particularly in the shallow areas like in the estuaries or in the mangrove areas, and but it here the surface layer of the sediments get disturbed. We cannot precisely collect the surface layer, but we can collect the surface sediments along at least 5 to 10 centimeters surface sediments that we can collect it here. And PVC pipe, we use it sometimes to collect sediment core from a during low tide. During low tide, we can collect use sediment core by using pipes. So by manually. So after we collect the sediments, we bring them to the lab. We dry them. We can do it hot air oven drying, or we can dry it. We do freeze drying. So here it is important to mention, say if you are measuring metals like mercury, in that case you cannot do hot oven air drying. Oven drying can release elemental mercury, or evaporate the mercury from the sediment. So in that case you have to do freeze drying, and for rest of the metals probably we can do oven drying. But now everybody prefers to go for freeze drying because it doesn't disturb the texture as well as the speciation of metals in the sediments. So after we dry the samples, then we grind it in mortar pestle, and then we go for acid digestion. The procedures I will be providing, so you don't worry about that. So during after acid digestion, we get all the samples in 2% nitric acid. So this media is fixed. This is 2% nitric acid. This digestion are usually done by using perchloric acid, nitric acid, and hydrofluoric acid. So it's this mixture of this mixture, we use it to digest the sediment sample. I'll provide you the procedure how to digest the samples, and then we digest it, and then after evaporate to dryness, we extract back in 2% nitric acid, and that 2% nitric acid samples we use it for the total metal determination in sediments. And this total metal can be done either by graphite furnace atomic absorption spectrometer or by inductively coupled plasma mass spectrometer called ICP-MS. So in graphite furnace, you get one element at a time, but you can measure the number of elements, at least 10 elements. 10 metals you can determine, or more than that. And in ICP-MS, in one single run, you can get almost 60 metals you can determine by ICP-MS. So after you get this metal concentration in your sediment, after all this procedure, then you can use those metal concentration to assess the quality of the sediments from a particular environment. And it can give you the idea about the quality of the environment, because the sediment reflects the environment, the overlaying water column, because it keeps the record. It takes the metals from the environment and it act as a sink. So if you look at the metal concentration in sediments, that definitely will give you some idea about the quality of the environment, the overlaying water column. And it can give lots of information about the past, whether any metal pollution event took place or not. So now there are several several indices are being used to assess the quality of sediment. So first one is contamination factor. So contamination factor, you already in the previous slide I showed that you say you are measuring metals and you have determined the concentration of different metals. Now you take one metals and you can calculate contamination factor for a particular metal. The contamination factor is used to express the level of contamination by each metal. So how do they do that? It's very simple. Contamination factor is basically the ratio of metal content in sediment of a particular metal content and the background value of the metals. Now what is background value? Background value means the concentration of the, say here the metal can say the concentration of lead in sediment that we have determined by graphite furnace or ICP-MS. And this is the concentration of lead in sediment which were present pre-industrial sediment, when there was no industrial influence or human activities. At that time, whatever the concentration, with respect to that, what is the concentration right now? So this is basically the ratio that that probably that gives the contamination factor. So if the contamination factor is less than 1, means it's a low contaminated by metal. If it is in between 1 to 3, that is moderately contaminated. Then 3 to 6, considerable contamination. And if contamination factor higher than 6, then that sediment is contaminated. But how to get this background value? How to get the concentration of a metal, pre-industrial metal concentration in the sediment from a particular area? It is difficult. But if you take a long core and if you date it, if you collect a sediment core, your surface sediment represent the present situation. Now, if you go down, this is basically because of the sedimentation, right? So if sedimentation is taking place, then this if you date it, then if this is a to 150 years back, say in this region. So at that time, probably industrialization was not, the human influences was not that high. On this metal contamination by human influences was less. So maybe this sediment we can take and we can look at the total metal concentration and see, and then consider it as a background value. Otherwise, what we can do, we can take the metal concentration, the particular metal concentration in upper continental crust sediments. These are available in literature. The concentration of different metals in UCC are available in literature. That can be used as a reference, and that can help us to calculate contamination factor. So I'll show you one example. Here I showed different metals like chromium, copper, cadmium, nickel, lead, how the contamination factor changes in different estuaries. Like here it is Ganges, Godavari, Krishna, Kaveri, Cochin, Ullas, Narmada, Tapi. These are not very clear, I think, in the slide, but I will provide you the material, the figures, and the papers where you can see that the contamination factor for chromium in the Ganges, which are in green color, are not, chromium, cadmium, copper, all these metals are not very much contaminated. The contamination factor is well within 2. But if you look at in Ulhas estuary, which is very close to Mumbai, the contamination factor for these metals are very high. So that means this Ulhas estuary is the sediments in Ulhas estuary is much more polluted than the sediments from Ganges. And if you look at the black color ones are East Coast estuaries from the East Coast, sediments collected from the East Coast, and brown one is from the West Coast. You can see the West Coast is relatively more, the contamination factor of metals in the West Coast is relatively more. So here again, I'll talk about these changes in the contamination factor from East Coast to West Coast, but you need to consider the geology also, that geology of the adjacent land. But we'll not go into detail of the influence of geology in total metal concentration. There are huge influences of geology of the adjacent land affects metal concentration. But here, if you just look at the contamination factor, it looks like East Coast is less contaminated than the West Coast. So here UCC was used as a background value, and you can assess crudely, grossly you can assess the quality of the sediment. But here individually you are assessing the sediments. But if you want to assess the quality of the sediment holistically, considering all the metals, then we use pollution load index. Pollution load index, where we calculate, contamination factor for each metals, like the way we have calculated here. So each metal we calculate, and then we say if there are n metals, then CF1, CF2, CF2 we multiply, and then nth root of that gives you the pollution load index. And if pollution load index is 0, indicates that there is no pollution. Pollution load index 1 indicates baseline level of pollutant, and pollution load index greater than 1 indicates progressive deterioration of the sediment quality, and sediment quality reflects the overlying water column as well as the environment. Here again I showed how the pollution load index in Indian estuary is changing with time. So in Ganges, I'll provide you the detail of this document. So don't worry, you just see how the pollution load index is changing in Ganges, in Kaveri, in Godavari it has gone up, but it is basically going down in the East Coast. But if you look at Ullas, again, the pollution load index is much higher than 1. So that means it is polluted, and that is because of the industrialization close to Mumbai city, close to Ullas estuary, and releasing of lots of effluent and sewage discharge, and so many high concentration effluent discharge in the Ullas estuary probably caused this high pollution load index in this region. So you can understand that this contamination factor and pollution load index are useful in understanding the quality of the sediment as well as the environment. There is another indices which is called Geoaccumulation Index. Geoaccumulation Index also calculated based on this equation, where Cn is the concentration of a particular metal and Bn is the baseline background value, and this background value again is considered, means you can consider for the concentration of metals in upper continental crust, or you can use it pre-industrial metal concentration, particular metal concentration in the sediments. And they have used 1.5, they just introduced as a background value due to lithological variation. So this is not very clear, because these things will vary from one place to another. So if the lithological variation here in the East Coast and West Coast, or somewhere in USA or in Europe, are not the same, so this equations are not very convincing. So here you can see the different classes, based upon the IGO value. It's unpolluted, unpolluted, moderately polluted, so extremely polluted is this. So these are very empirical. These are very gross. I mean, the limitation of these indices to assess metal pollution or the quality of the environment with respect to metal is, we need to have, particularly in case of India, we need to have a very systematic analysis, systematic investigation all around the country, which is not there. Contamination factor and geoaccumulation index and pollution load index of marine sediment oversimplify the complex geochemical processes that are involved in coastal marine system. And total metal concentration in sediment, what I strongly believe, doesn't give any information about their bioavailability. I'm giving an example. If you think that, total mercury, if you determine total mercury in sediments, can it give you any idea about the concentration of methyl mercury? No, which is a neurotoxin, right? So total mercury cannot give you any idea about the bioavailability of mercury. Similarly, total lead cannot give you any information about its bioavailability, its fate, its mobility. So we need to have a better tool to understand metal pollution in a system. So from this discussion, we found that contamination factor, pollution load index, geoaccumulation index can be useful to grossly evaluate the status of sediment quality of a particular area, and these indices, but at the same time, these indices oversimplify the different biogeochemical processes, and we need a better tool to estimate metal pollution. So in the next module, what I will do, I will talk about a modern tool which can help us to assess the metal pollution in marine environment, and we'll discuss about its how to use those that new tools in particularly marine system. So we'll meet in the next module. Thank you.